Best practices to benchmark deep models on CPU and NotPoo in PyTorch. I am little uncertain about how to measure execution time of deep models on CPU in PyTorch only for inference. I list here some of them, but they may be inaccurate. Please correct them if required and mention more if required. I am running on PyTorch version 1.3.1 and Intel Xeon with 64 GB RAM, 3.5 GHz processor and 8 cores. Should we use time.time? I know that for Poo this is a very bad idea. For Poo I do as follows. For this code, execution was done on Poo. If I have to run them on CPU, what changes should be made? Will time.time do? Should we use volatile? I think the use of volatile is now discouraged after v0.3. But will it still help if I use the eval mode and no_grad? Should the page cache be cleared? One way of doing this that I know is using sudo shc/bin/echo1 is greater than break time equals 1/. Should I remove nn.sequential and directly put in forward part? According to this link. All the methods using copy underscore take some time to execute, especially on CPU this might be slow. Also the nn.sequential modules are slower than just executing them on the forward pass. I think this is due to some overhead that needs to be created when executing the sequential module. Another thing which I do not understand on the same link is, if you are running into performance issues with these small numbers, you might try to use torch.set_flush_denormal_true to disable denormal floating point numbers on the CPU. Should torch.set_num_threads be used? If yes, can a demo code be provided? What does these context managers are thread local, so they won't work if you send work to another thread using the column module, column threading module, etc. mean as given in the documentation. Please list any more issues for calculating execution time in CPU. Thank you.
Should we use time.time? Yes, it's fine for CPU. Should we use volatile? As you said, it's deprecated. Since 0.4.0 torch.tensor was merged with torch.variable, it's deprecated as well, and torch.no_grad context manager should be used. Should the page cache be cleared? I don't think so unless you know it's a problem. Should I remove nn.sequential and directly put in forward part? No, torch.nn.sequential should have no or negligible performance burden on your model. Its forward is only. If you are running into performance issues with these small numbers, you might try to use torch.set_flush_denormal_true to disable denormal floating point numbers on the CPU. Flushing denormal numbers, numbers which underflow, means replacing them strictly by 0.0, which might help with your performance if you have a lot of really small numbers. Example given by PyTorch docs. Should torch.set_num_threads be used? If yes, can a demo code be provided? According to this document, it might help if you don't allocate too many threads, probably at most as many as cores in your CPU, so you might try 8. So this piece at the beginning of your code might help. You may want to check numbers out and see whether and how much each value helps. What does these context managers are thread local, so they won't work if you send work to another thread using the module threading module, etc. mean as given in the documentation. If you use module like torch.multiprocessing and run torch.multiprocessing.spawn, or a-like, and one of your processes won't get into the context manager block, the gradient won't be turned off, in case of torch.no_grad. Also, if you use Python's threading, only the threads where the block was run into will have gradients turned off, or on, it depends. This code will make it clear for you. Which outputs order may vary. Also notice that torch.no_grad in _main_ has no effect on spawned threads, neither would torch.enable_grad. Please list any more issues for calculating execution time in CPU. Converting to Torch script, see here, might help. Building PyTorch from source targeted at your architecture and its capabilities and tons of other things. This question is too wide.